Time for more examples with implicit differentiation. So for this first one, I want you to pause the video, try it, and resume the video when you're ready to see the solution and hear some comments about it. And here's a solution. So apply the ddx operator, and again, y prime, what we're looking for is dy dx, and so when we go through this, we notice that we encounter differentiate a term that contains y in the first and second terms because we have to use the product rule in the second one, but so if we're differentiating a variable per normal rules, but that variable is not our variable of interest, x in this case, we have to include that implicit differentiation term. Okay, and after that first critical step, a lot of algebra ensues, and so you have to isolate the terms containing dy dx to one side. That's what I did in my third step, and remove that common factor, and then move everything that doesn't have a dy dx to the other side, and then finally solve for dy dx. Okay, but usually with implicit differentiation, the first step of when you're actually doing the differentiation, remembering that dy dx, that's the critical part. Okay, whenever you differentiate something that is not your variable of interest, include that term. All right, the next one I kind of like. It is an alien graph, so we'll find its derivative, and then we'll take a look at the function. Okay, so applying the implicit differentiation operator. Okay, so if we differentiate sine and we're following the chain rule, we would get cosine and then recopy the inside function. And then we have to continue differentiating, so now differentiate the inside. So we would multiply by 2x plus 2y dy dx. Yep, we differentiated y, so we need the dy dx. And then here we have a product rule on the other side, so y squared times the opposite of sine of x, so 1 d2 plus 2 cosine x d1 2y dy dx. Okay, so now there's going to be a little bit of ugliness because we have to distribute cosine to each of those, and we want to ultimately collect the dy dx's to one side. Okay, I'm going to skip ahead in the solution. If you want to stop and pause and do the algebra, I encourage you to do so. Once you get things isolated, you get y prime dy dx, okay, whatever you want to write, times 2y times cosine of x squared plus y squared minus 2y cosine of x. On the left side, on the right side, you'd have the minus y squared sine of x, and then minus 2x cosine of x squared plus y squared. And then certainly you have to divide that other nasty chunk over in front of the y prime. So you have a fraction, and you have minus y squared sine x minus 2x cosine of x squared plus y squared, and then 2y cosine of x squared plus y squared minus 2y cosine x. Okay, and so with this, if you wanted to, you could maybe simplify it a little bit by, most of the terms contain 2, so maybe you want to not write 2 all the time and write 1/2 as a coefficient of that the first term in the numerator. You could do that. Make easy simplifications, but don't stress too much about trying to simplify this thing. Okay, so let's take a look at the graph now. And for fun, here's the little alien, so you can see his it's 2 eyes. We don't want to apply a gender that we don't know about. We can see its two eyes, its head, and its ears. So kind of a little fun function. And now that we have the implicit differentiation tool and we found the derivative, we can express the derivative at any point on this function. So we know like the curvature of its head, its head, and so on and so forth. So kind of fun. A little application of implicit differentiation.